Hello everyone. Today I will be explaining you about regression metrics, specifically MSE, RMSE, MAE, and R squared. So these metrics are widely used to evaluate the performance of regression models, and they help us to understand how accurate and inaccurate our predictions are. So let's dive into this topic. When we build regression models such as house price prediction and stock price prediction, we need to analyze how accurate or inaccurate our models are trained. Simply looking at predictions is not enough. We need to look how incorrect or correct our predictions and how far off the predicted values are from the actual values. That's where the regression matrix comes in. So, for example, if I build two models for house price prediction, I can see which model performs better by using this regression matrix. Now, let's see what are these regression metrics. So, commonly, there are four regression metrics used, which are MSE, which is mean squared error, second is mean absolute error, third is root mean squared error, and the last one is R squared. So mean squared error measures the average square difference between predicted and actual values. Root mean squared error is just the square root of MSE. So it's easier and in the same units as the data. And MAE, which is mean absolute error, is that takes the absolute value of errors and averages them and makes it more robust to outliers. Finally, R squared tells us how much the variance in the data is explained by the model. A value close to 1 means it is a better fit, and a value close to 0, it means that it is not a better fit. So now let us have some look on how these evaluation metrics are actually implemented. For MSE, we calculate the difference between actual and predicted values and then square it and also then average it. Whereas RMSE is just the square root of MSE. For MAE, we take the absolute difference and then average it. And for R squared, we use the formula 1 minus the ratio of residual sum of squares to total sum of squares. In simpler terms, R squared compares how much better the model is compared to just using the mean of the data. For example, if I predict actual values like 352 and get predicted values 2.5, 5.5, and 2, I can calculate each error step by step using these formulas. So now let's see what are the challenges and limitations faced by these metrics. First, MSE and RMSE. So the problem here is they actually hate outliers because they square the errors. Even one really bad prediction can mess everything up. Imagine I'm predicting delivery times, and if I am late by a few minutes most of the time, that's fine. But if I just once I predict 2 hours late, RMSE will suddenly jump and make my model look terrible. Now, MAE is a bit more forgiving for outliers than MSE and RMSE. It just takes the average of errors, so it's not shaken by one bad prediction. But the flip side is it doesn't care whether the mistake is small or huge. It treats them the same way. So a 2-minute error and a 2-hour error both look the same. And now the R squared error. This one is actually tricky. A high R squared error sounds great, right? But it doesn't always mean the model is actually good. For example, if the relationship in the data is non-linear and I force a straight line, I might still get a nice R squared, but the predictions will fail. Also, if I have a very tiny dataset, R squared can give me false or sense of confidence that our prediction is right, but it is actually not. So basically, none of these metrics are perfect on their own, but there are some things like that's why we don't rely on one metrics. Uh, there are, I think, so to choose an evaluation matrix, it depends on the application or the model we are trying to build. So now let's sum up these evaluation metrics real quick. So these evaluation metrics are just ways to check how good our model is doing or how bad our model is doing. MSE and RMSE care a lot about big mistakes. So if your model messes up, these numbers skyrocket. MAE is simpler and treats all the mistakes as the same. R squared shows us how much of the data's variation your model can explain in simpler terms, but it's not perfect. So the most important thing here is we need to mix a bunch of these metrics together instead of relying on just one metric. So it basically depends on our application that we are trying to build, and that way you really know how well your model is performed. So thank you for listening to this video very carefully. I hope you understood all my points. Thank you.